lesson 3-2b. This is the second half of lesson 3-2. We're going to be talking about the least common multiple. What is the least common multiple? These words, they seem familiar, but yet different. So let's look at them. Multiple. What is a multiple? The multiple of a number is like counting by that number. So for instance, 3. If I counted by 3s, I'd be listing the multiples. 3, 6, 9, 12, 15, 18. I can keep going and going infinitely, forever and ever and ever, until I get tired, or you get tired of watching. But it keeps going. And likewise, I could do the multiples of 4, which would be 4, 8, and so on and so forth. So now I have multiples of two different numbers, and now I want to find which ones they have in common. Remember, that word means they share it. They both have it. Like you might have a common interest with a friend. So let's look and see which numbers they have in common, which multiples they have in common. Well, it looks like they both have a 12, and they both have a 24. And actually, they would both have a 36. I didn't go that far with 3. But it is. You can see every 12, actually, I have another common multiple. And so I have an infinite number of common multiples of 3 and 4. But what I'm looking for is the least of them all. I'm looking for the least. And so if I did that, the least is the smallest. That would be 12. So the least common multiple of 3 and 4 is 12. So let's look at a couple ways to find this least common multiple. Well, we can always do it the way that I just did with 3 and 4. What I usually do is I list the bigger one, the multiples of the bigger one, until I see when it looks like it's a multiple of the smaller one, so I don't have to keep going on forever and ever. So let's go ahead and do that. 18, 36. Oh, 36. I recall that's a multiple of 12. Well, I could keep on listing. But since I recognized 36, I didn't need to do that. So anyway, the multiples of 12 are 12, 24, 36. There it is. So the LCM of 18 and 12 is 36. Now, sometimes listing the multiples, and they can go on forever and ever and ever before you find a least common multiple. So you also can use factor trees. So I'm going to do the prime factorization of 18 and 12. And when I do that, I have all the ingredients of an 18 and all the ingredients of a 12. And multiples of 18 and multiples of 12 have those numbers in them as factors. So what I need to do is I need to have all the factors, so least common multiple, I need all the factors of an 18, a 2 times 3 times 3. So now I can divide it by 18 if it has a 2 times 3 times 3 in it. And I also need all the factors of a 12. Well, I already have a 2, and I already have a 3. I need another 2. So I'm going to tack a 2 on there. And then when I multiply them together, I get my 36. 2 times 3 is 6. 2 times 3 is 6, and 6 times 6 is 36. And so that's how you'd use factor trees to find the least common multiple. Okay, so now we have 21 and 7. And I'd like you to give this one a try, and we'll talk about it in class tomorrow. Here's another example. This time I have 3 numbers to deal with. So you can go ahead and you can list the factors of them. So we have 21, and I can have a 21, a 42. There we go. And after doing that, I seem to have 42 as a common multiple. That seems to be the least common multiple. 21 is not is shared by 7, but not 14. And so there we go. That's the smallest. Now, let's look at this as using factor trees. All right. Well, 21 is just 3 times 7. 7 is already prime, so 7 and 1. 14 is just 2 and 7. And so those are the prime factorizations of those numbers. So for our 21, the LCM, for the 21, I need a 3 times 7. So I already have the 7 I need for 7. I already have the 7 I need for 14, but I need this 2 because I don't have that yet. And so I get 42 when I multiply those together. I think that's actually easier. Okay, let's put this newfound knowledge to use. Grant is making picnic lunches, and I guess he doesn't care how many lunches he makes, as long as he has the same number of juice bottles as applesauce cups. He's going to pair them together. He wants no extras of either. And so apparently we want the least amount of packs we can make. Interesting way to feed people at a picnic. So anyway, if I were to list the multiples of 6, that would tell me the possibilities for how many juice bottles I could buy. If I listed likewise the multiples of 8, I could know how many possible cups of applesauce I might have. I made a little table. I would normally find this just by finding the least common multiple, but let's show how this works. Now, with the juice, if I bought 1 pack, it looks like I get 6 bottles. So 1 pack would give me 6 bottles, 2 packs, 12, 18, 24, 30. If I bought 6 packs, I get 36 juice bottles. Looks like multiples. The applesauce, if I buy 1 pack of that, I get 8 cups. So there's 8, 16, 24, 32, 40, and 48. And I'm looking for the first one that matches, the least common multiple. And it looks like 24 is it. So if I plan on getting 24 applesauce juice combos, that means I would have to buy 4 packs of juice and 3 packs of applesauce. Those both would give me the 24 I need. And so there you go, 4 packs of juice, 3 packs of applesauce. Well, let's see if we could do this with the factor tree method. I'm going to quickly do my factor trees for 6 and 8. And then I know that for my least common multiple, I need a 6 in it, so I need the fixings of a 6. That's a 3 times 2. If I go up and look at my 8, I already have a 2, but I need 2 more 2s, don't I? So I need 2 more 2s. And now I can say, well, this is 6, this is 4. 6 times 4 is 24. I get the same answer. Well, here's another question. Same idea. Now he's buying bottled water and juice pouches for the picnic. There's 12 bottles of water in a case, and there are 10 juice pouches in a box. And so we want to know the least amount of each he can buy, but have the same number of each. So if we bought 1 pack of each, 1 case of water, 1 box of juices, we wouldn't have the same number of each. We'd have 12 of one and 10 of the other. So how many of each do I need to buy so I have the same amount of each? And I'd like you to do, you can do it through the listing method, listing the multiples. And I'd like you also to try the factor tree method to see if you can do it. All right, we'll talk about this next time in class. Here we are with the straight up practice, wrapping things up. We're looking for 2 quick least common multiples, one for 8 and 12, one for 4 and 14. And what I'd like you to do is, you can list it. You can do factor trees, whatever floats your boat. In the end, listing might be more intuitive and easier to understand. The factor tree is going to be more powerful and for harder problems where you might be listing forever and ever and ever with the old method. The factor tree does it very quickly and efficiently. So anyway, go ahead and try those, and see you next time.